this should be a pretty short video, and I want to go over these evolution by random processes. This is in the book, but I think these examples will help you understand these pretty well. And those four processes are mutations, genetic drift, bottleneck effect, and founder effect. So this is evolution by random processes. There's no selection going on. With natural selection and with artificial selection, there's actually some kind of selection pressure. Either it's some selection pressure from nature, like predator, or it's artificial selection that humans put on a species. But random processes is just like it says. It's random. There's no selection, or the selection is random. So the first example is if you have a mutation in a population where you had, let's say, all white rats, and then all of a sudden there's a black rat in there. Over time, you're just going to have more of those alleles. That phenotype, that genotype, is going to be more prevalent in the population if it's not selected for or against. Just by random chance, that allele will spread through the population. So that's called a mutation. It occurs randomly. A lot of different kinds of mutations. Some are caused by ultraviolet radiation. Some are just replication errors. Some are chemically induced. But mutations happen. They can add valuable variations to a gene pool. Okay, here's a different one. So in a large population, organisms are always dying and by random reasons, not always being selected for or against. But that randomness, that random change isn't going to amount to much because there's so many in the population. You can just randomly take a few out and the proportions aren't going to change. But if you have a small population, let's say really literally this is only 5 there, and a couple die that just happen to be black in this case, after a while there might not be any ones left. And it's not because the black ones were inferior in any way. They just got randomly squashed or died, or it had nothing to do with the color of their fur. But now they're all gone out of the gene pool, and so that population evolved, and that evolved randomly. So that's called genetic drift. And it's going to affect small populations much more than large populations. It affects the diversity of the population because a small change proportionally is a much greater, larger in a small population. So where this comes into play is that if you have geographically isolated populations, so geographically isolated meaning you have one population but they get separated for some reason. One's on one side of the mountain, another's on another side of the mountain, and they're just isolated. They're not mixing. Well, one population is going to drift, genetically drift in one direction, and the other population is going to genetically drift in another direction. That can happen long enough that when they're rejoined later, the populations may have become reproductively isolated. What that means is that they might look different enough that they're not attractive to the other population. And so even though that they're now geographically together, they're reproductively isolated because they're not reproducing. And we're going to see an example of that in a movie. So they won't interbreed. Even though they could, they're not. So here's an example of, for some reason, these 4 little mice right there are going to float on a log and populate some island. And it's just kind of random that those 4 mice found themselves in some log and went to this island. Or maybe they even planned it. You had some mice getting together and say, hey, let's go over to that island. Kind of doubt it. But it was random. The phenotype ratios was random. So now that island, for whatever reason, doesn't have those tan mice. And it's not because the tan mice wouldn't have worked out on that island. It's just that no tan mice went to that island. So we call these the founders of the new population. And so that's a kind of evolution. That tan phenotype is kind of weeded out because of that random choice of who went to the island. So that's called the founder effect. And it's a loss of variations because the colonizing group is small. Now this next one, okay, so the new population is now geographically isolated, right? They're not gonna, those two populations aren't gonna mix anymore, so they're gonna evolve separately without those traits. This next one is very similar and is a very important one to apply. So in the founder population, one group went off, just like in this, those 3 mice could have gone off and founded a new population. In this case, those mice are the only ones that just happened to survive some big calamity. So those were the survivors. And this is some calamity that was random in the way it chose who survived. It might have been a massive forest fire that killed most of them because they just were there. There were just randomly some other individuals that weren't in that forest. So that means the new population now has a new phenotype ratio. And the whole population is going to stem from those. So in that case, the white ones, even though look at all the white ones in that population over there, that small subset that's happened to survive had no white ones. Not because it wasn't a desirable trait, but again, it was just randomly selected out from that initial group that survived. And now the new population has lost that phenotype. So that's called the bottleneck effect. And that's the loss of variations, again, due to a shrinking population. In this case, because of a calamity. This is a big deal when it comes to endangered species, because in endangered species, you might have, tens of thousands of, say, Bengal tigers that used to exist, probably hundreds of thousands. And now there's something like 400. So they're going to go through this bottleneck effect. They've lost a lot of really important traits, a lot of variations that could be useful. And so they're going to have a really hard time adapting. And we know that the Earth is always changing, so species always have to adapt. And so endangered species really have a tough time adapting for that reason. So here's just another example of, the analogy here is pretty obvious here. You shake a few out, and for some random reason, there were no red ones in the bottle, and so now the new population has no red ones, or green ones for that matter. So even though the numbers might be big, and it's a problem because there's not much genetic diversity there. So that's a catastrophic reduction in population. So there you have it. There's 3 different kinds of evolution by random processes: mutations, genetic drift, bottleneck effect, and founder effect. The one I think that is the most important that you can apply to our unit right now is the bottleneck effect. Make sure you know that one and how it applies to endangered species.